What in the event that CERN has faltered upon something so earth-shattering that it revamps everything we thought we knew? Settled within the heart of groundbreaking investigate since the 1950s, this incredible center has continuously was a tease with the edges of logical understanding. What does this startling revelation cruel for us? Let's burrow into this disturbing disclosure, uncovering the insider facts of the universe. Point one of CERN's most popular ventures is the Huge Hadron Collider, LHC, the world's biggest molecule quickening agent. It extends over 27 kilometers in a circle and taken a toll over $4.5 billion. Numerous contend this was cash well went through since the LHC has driven to a few of the greatest disclosures in later a long time, like finding the Higgs boson and other obscure particles. This gigantic machine can speed up different particles around its circle until they are nearly at the speed of light, completing over 11,000 laps per moment. This is often conceivable much obliged to greatly capable electromagnets that make an attractive field interior the quickening agent, which is over 1,000 times more grounded than the Earth's common attractive field. A few individuals were stressed that producing such a solid attractive field might influence neighborhood hardware and indeed the Earth's attractive field. When these particles reach their greatest speed, which is 99.999999% of the speed of light, they are made to collide with each other in effective crashes that discharge tremendous sums of vitality and different particles. These molecule collisions make showers of particles that scramble in all bearings, existing as it were for minor divisions of a moment sometime recently vanishing. By utilizing distinctive sorts of particles, analysts can find modern particles in these bursts. Super touchy locators are set around the collision locales to capture all the data from each collision. The sum of information collected from these tests is colossal and significantly includes to our understanding of the basic parts of the universe. This investigate at CERN keeps pushing the boundaries of human information, challenging our understanding of the physical world, and driving the improvement of unused advances and hypotheses. But the real surprise is just how much we still ought to learn almost our universe. The expansive Hadron Collider could be a bustling put where researchers from all over the world collect gigantic sums of information from minor molecule collisions each year. These tests create over 15 petabytes of crude information. In 2017, the LHC accomplished a major turning point by putting away over 200 petabytes of information in its tape libraries. To put this in viewpoint, 1 petabyte equals approximately 250,000 motion pictures. Researchers are continuously seeking out for anything bizarre within the information. As of late, they take a note something odd with a type of molecule called the magnificence quark. Quarks are the essential building pieces of everything and come completely different sorts or flavors. The excellence quark, based on the Standard Model, a system portraying the behavior of essential particles, should run into lighter particles called leptons, either an electron or a muon, due to the frail constraint. But the LHC information appeared something bizarre. Magnificence quarks were decaying into muons 70 times more frequently than into electrons. Ordinarily, this ought to happen equally regularly, about 50/50ths. This unforeseen ratio suggests there could be an unused sort of molecule included, driving a few researchers to think there may be unused material science past the standard demonstrate. Finding an unused molecule might alter our understanding of material science and reply numerous uncertain questions. The standard demonstrate is exceptionally exact, but as it were clarifies 3 of the 4 principal powers: electromagnetic, solid, and frail powers. It doesn't incorporate gravity or clarify dim matter, which makes up most of the universe. This irregularity with the magnificence quark might lead to groundbreaking revelations, indicating at physics we do not, however, get it, and possibly changing how we see the universe's basic workings. The explore for this modern molecule and the powers it might reveal proceeds to energize researchers, holding the promise of more profound experiences into the puzzles of the universe. Modern discoveries at the LHC challenge what we know almost particles and the powers that govern them. The irregularity proposes that our current understanding can be incomplete, pushing researchers to investigate modern thoughts. In a later explore, The Huge Hadron Collider found information that didn't coordinate the regular rules of particle physics. Whereas it's ordinary for comes about to some of the time be distinctive, this case got a lot of attention from scientists. They are now looking closely at this interesting result to see what it means. The fervor is around a conceivable modern molecule called Z prime. This molecule might be an unused kind of drive, but exceptionally frail, which is why we haven't taken note at some time recently. Researchers think this constraint might connect it in an unexpected way with electrons and muons compared to other known strengths. In case they affirm this unused constraint, it may alter a parcel. For a long time, physicists have been seeking out for clues to help understand big secrets of the universe, like dark matter or the genuine part of the Higgs boson. A few indeed think this unused constraint might offer assistance to unify all the elemental forces of nature, which is a major objective in material science. In case Z prime is genuine, it may open modern entryways in material science, giving us understanding to solve some of the greatest questions around the universe. CERN's continuous inquiry about might fair lead us to a major breakthrough in our understanding of everything around us. The Huge Hadron Collider, a captivating test, speeds up particles to a mind-blowing 99.999999% of the speed of light. These particles are sent in inverse headings and after that crash into each other with incredible drive. This collision isn't fair a cool science trap. It makes a colossal sum of vitality and shapes numerous unused particles. When these particles collide, they scramble in all headings, but they as it were final for a really brief time. Most vanish nearly right away. Right where these tests happen, there are exceptionally touchy locators. These locators are put carefully around the collision focuses, and their work is to capture each detail from these fast intuitive. The sum of information collected is gigantic. Each year, the LHC assembles over 15 petabytes of crude information. To handle and think about this tremendous sum of data, analysts spend incalculable hours going through it carefully. By 2017, the LHC had put away over 200 petabytes of information in its expansive tape libraries. To put this in point of view, 1 petabyte can hold almost 250,000 motion pictures. You might ponder why they collect so much information. Among the numerous disclosures, one curiously discovered is almost the behavior of a particular sort of quark called the excellence quark. Quarks are the building pieces of matter and come completely different sorts, each with one-of-a-kind properties. These types can alter rapidly, turning into other particles nearly quickly. The excellence quark, which changes in a trillionth of a moment, as of late appeared a few shocking behaviors that didn't coordinate what researchers anticipated. Agreeing to current hypotheses, when excellence quarks alter, they should turn into lighter particles called leptons, particularly electrons or muons, and rise to sums. The LHC found that magnificence quarks were changing into muons 70% of the time, much more regularly than into electrons. This interesting finding recommends there may be an obscure molecule influencing these changes, implying at modern material science we haven't found, however. This seemed cruel, unused molecule that carries a constraint we don't know almost, conceivably changing our understanding and growing the standard demonstrate, which is the most system of molecule material science. The standard demonstrate clarifies molecule material science exceptionally precisely, but it's not idealized. These unordinary quark changes raise huge questions that challenge the model's completeness. Could we be on the skirt of finding unused crucial powers or particles? The progressing investigate at the LHC isn't as it were investigating the profundities of molecule material science, but too holds the potential to alter our understanding of the universe's fundamental powers and structures. Presently, let's see how these disclosures might change our primary material science hypothesis. The journey for the slippery Z prime molecule proceeds. The standard show of molecule material science depicts 3 essential strengths: electromagnetic, solid, and powerless strengths. In any case, it doesn't clarify gravity or dull matter, which makes up most of the universe's matter. As of late, researchers found something abnormal in their tests that didn't coordinate their forecasts. Whereas startling comes about are common given the huge sums of information from the expansive Hadron Collider, this finding caught researchers' consideration and driven to assist examination. Researchers think this inconsistency might recommend a modern principal drive in the presence of an unused molecule, conceivably called Z'. This molecule may be a constrained carrier, but is thought to be exceptionally powerless, which is why it hasn't been taken note sometime recently. A few accept Z' might connected in an unexpected way with electrons and muons compared to known particles, but how it fits with other particles within the standard show is still hazy. Finding an unused force-carrying molecule would be a gigantic breakthrough in material science. It may offer assistance reply huge questions almost the universe, just like the riddles of dull matter and the Higgs boson. A few researchers trust this could even lead to binding together the crucial powers, an objective that has been sought after for over a century. Elon Musk lauded CERN for their work on the expansive Hadron Collider, the world's biggest and most effective molecule collider. Built between 1998 and 2008, this enormous venture included over 10,000 researchers and hundreds of educate from over 100 nations. The collider is found in a 27-kilometer burrow on the French-Swiss border close Geneva, around 175 meters underground. Since it started working, the LHC has set vitality records, with the primary collision coming to 3.5 tera-electron-volts per pillar, nearly 4 times the past world record. Later improvements permitted it to reach 6.5 tera-electron-volts per pillar. Musk famous that the LHC can quicken not fair proton pillars, which are primarily utilized, but moreover lead particle bars. Each year, for around a month, the LHC tests collisions between protons and lead particles to look at different hypotheses in particle physics. These continuous tests are significant for understanding the essential components and strengths of our universe. And this isn't where the fervor closes in material science. The Higgs boson, frequently called the Higgs, grabs the consideration of researchers all over. This little molecule is connected to the Higgs field and speaks to the vitality that comes from that field, much just like the waves you see when a shake is tossed into a lake. In spite of the fact that individuals regularly listen the term molecule, it's not precisely right to think of the Higgs as a molecule you'll choose up or toss. Instead, it's a swell in an imperceptible field that's spread all over the universe, affecting other particles, like giving them mass. This idea isn't fair and unique concept. It shapes a key part of the standard show of molecule material science, typically a system that has molded our understanding of the physical world since the 1970s. It's so central to material science that when its discovery was reported in 2012, it was a worldwide occasion. Analysts celebrated not fair for including a chunk to a logical confuse, but for affirming a decades-old hypothesis that explained how a few of the universe's building squares pick up mass. But let's not fair conversation approximately truths and figures. Let's think approximately what these revelations cruel. The Higgs, in its unique way, acts as a bridge between science fiction and our real-world understanding. It's secretive and tricky, frequently portrayed as